Hey everybody, in this video we're going to go over Newton's second law of motion, which is an equation that we're going to use to solve problems and figure out how fast an object can speed up or accelerate. So this is Newton's second law. You might have heard it before, called F equals ma, but it's important that we write it as F net equals ma. Alright, now F net is the net force. Net force. Not just any force, the net force. So let's define what net force is. The net force is the sum, the addition, or the sum of all the forces on an object. So if you take all the forces applied to an object and you add them up, you get the net force. It's the word net means overall. So it's kind of like if somebody gives me $10 and then I spend so if somebody gives me $10 and I spend $5, what did I net? I netted $5. Somebody gives me $10 and I spend $6, what did I net? I netted $4 plus $4. If somebody gives me $10 and I spend $20, what did I net? Negative $10, you know? So the net force is like when you just add the two together, what you got more of and what you got less of. And you add them together and you get your overall or your net, okay? So let's show how we're going to use this equation to solve problems. We need to learn what a force diagram is. A force diagram is a box which represents an object. We're going to represent all our objects with boxes. And with forces on that object represented by arrows. Do you remember your force diagrams when you did terminal velocity and you studied that topic? There was the air resistance and there was gravity. Now those are for a skydiver. Now we're going to deal with force diagrams for objects on a level surface, kind of like something like my phone sitting here on the desk, okay? And we're going to slide our objects left and right in our problems today, and we're going to draw a force diagram for that, of an object sliding left and right on a level surface. So we'll draw a box to represent our object, say the phone, and I could push the phone forward, and that's a force from my hand, that push. Sending it forward, we're going to call it to the right. And that push from my hand is called the force. It's called FP, the force of push. But, you know, if I pulled the phone, it could also be called the force of pull. It's still a P, so that works. Force of push or pull. It's whatever somebody applies to the object with their hand. Alright, so that's FP. That's the force that's going to speed up the object. But there's always a force kind of preventing us from speeding up called FF. And that force is going to work against the way we're moving. It's going to work against the push or the pull. FF. You might have an idea what that is. It's called the force of friction. Whenever you have something sliding or scraping on the ground or any surface, there's friction slowing it down. So FF is the force which prevents me from speeding it up. You could hear it. Shh, it's like scraping. That is the force of friction that you're hearing. Okay? So in our force diagrams for all of our problems, FP will be to the right, speeding up the object. FF will be to the left, slowing it down. The push and friction are working against each other. All right? And those two forces are going to add up together. They're going to make the net force. the overall force on the object. All right? So let's write that down. FP and FF sum, remember sum just means add up, to make the net force. So for all of our problems that we're going to do, you could write Newton's second law like this, which we gave you already, but I'm going to let you just write it like this. FP, it's the positive force to the right, minus FF. Why? I thought you were supposed to add the forces together, FP and FF. Well, the FF is to the left, which means it's a negative. Okay? It's preventing us from speeding up. So the net force is really FP plus a negative FF. So I'm just going to write it as FP minus FF because they're working against each other. And then we could write equals MA. So for all of our problems, you could just start Newton's second law like this. FP minus FF equals MA. Okay, because we're just going to use those two forces and focus on that. Okay. Now M, just review, M represents the mass and A represents the acceleration. All right, so I could like double bold this here for you, and that is what you're going to plug your numbers into right there to make it obvious. All right, good luck.